Hey guys, Shane here for Fugatech 3D Printing. Today I'm going to show you how to install a 12 volt silicon heat pad on the Folgertech FT-5. So welcome back guys. So this video I'm really making as a reference point for so many people out there who want to get more out of the Folgertech FT-5. This question comes up at least 2 or 3 times per day in the Folgertech 3D Printing Facebook group, and I answer it all the time, and I give my recommendations. I give this recommendation because I've used it, it works well, and I really recommend it. If you want to get a quicker heat up time on your heated bed, this is really needed. If you want to print ABS or some of the other, I don't know, like what was it, nylon I printed the other day, you need to have your heated bed 90, 100 C. Well, the stock bed is not going to get there, period. Unless you put a 24 volt heat power supply on it, or if you overvolt it to about 15 volts, it'll get there eventually. But it takes a really, really long time. You'd have to insulate it. But if you want to just bypass all of that, spend the least amount of money that you have to, I think total this ended up being 50 bucks, and you actually have a lot of spares of these things here. It will be well worth it on top of your price of $500 for the FT-5. So let's dig in, let's look at the parts that we need to do this. We'll go through the printer, show you how it is stock, how it is with the setup, and we'll see how much better it performs. So the very first thing we need obviously is the silicone heat pad. So here's the 3D top, 12 inch by 12 inch, 12 volt silicone heat pad. I picked this up on Amazon. I'll put an affiliate link down below. You guys can pick this up and help out the channel. The other thing we're gonna need is a 100K thermistor, which I already have here attached, and it's actually just gonna sit right on the bottom. You could tape it if you want to. Really don't have to though. And then I have added on just this cable management cord to make things a little bit easier for routing it. You don't want to have all these cables going everywhere. The leads on the 3D top are shorter than I would like them to be, but it is what it is. It really doesn't matter all that much. You just have to strip off the ends. I can't actually remember if these were stripped or not when I bought it, but either way, strip off the ends. You have your thermistor there, and you'll notice here is where the leads connect. You see this bulge here, and it comes up quite a bit, So we can't just slap this down on top of the current heated bed, which is what I recommend. I recommend you leave the stock heat bed there, and we're gonna put this setup right on there. But we need something between the heated bed and our new silicone heat pad, and for that we're gonna use cork tiles. So we're gonna need a cork tile, and a pack of these was 4 in a pack for, I believe it was $10 or $12. You probably can find it cheaper somewhere, but links are down below for this. So I bought it off of Amazon, and it's real flexible. These are just like cork tiles for the wall. They are 1/4 inch thick, so they're real nice. So this is actually gonna act as our insulation and our clearance mechanism, we're gonna call it, so that we can have the new silicone heat pad sit flush on top of the heated bed. So all we have to do is cut out, so you can measure from each side, make it as precise as you want or imprecise as you want. It's really up to you. It doesn't matter necessarily as long as you get roughly the shape that is. So we're gonna cut the cork and then show you what it looks like. For the magic of the internet, it is cut. So you can see here, if I hold this up, you put your thermistor is gonna sit here right between. Will match up with our cork, and there it is. You see that fits in there just right. I could make it probably a little bit bigger, but it fits in there pretty much perfectly straight around. You see all of our sides line up, and you don't need any sticky backing. I personally don't recommend a stick backing, simply because what if something happens? What if you want to change out your build plate? I have what, 4, 5 different build plates for the FT-5 with different build surfaces on them. Now granted, I do YouTube, companies have sent me these, I've bought them, I'm testing out different build surfaces to see which one works the best for which materials and things like that, but still, you might want a print bite, you might want a build tack, you might want a PEI, and you might want just flat glass, so you can print straight on the glass or use glue or hairspray, whatever floats your boat. But that's 4 build plates right there. So what are we gonna use for these build plates? Well, a very nice, cheap, easy solution is a mirror tile. So hello world. So I'm gonna hold it this way just so that glare is not there. This is a 12 by 12, 1/4 inch. I think this is what, 3 or 5 millimeter, whatever that is in millimeters, I don't know. I got this at Lowe's, and it was a pack of 10 for $10. was 10 for $10, 6 for $10. Anyways, links will be down below. I don't remember what it was, but I'll find it when I go to edit this. These are fantastic. They are super flat. So the nice thing about a mirror versus a glass tile, the glass tiles you're going to buy are probably going to be pretty doggone flat. But with a mirror, you guarantee flatness, simply because if it wasn't flat, you'd have a distorted image. So you're guaranteed to have a super flat surface with the mirror tile. So now let's review how we're actually going to stack all this up. We're going to do stock heat bed. So the one that's already there, it's already hooked up. I use the 4 screws in the corners. I don't use the ones on the sides. So that is going to be how you level the bed. Then we're going to go ahead, we're going to stick our cork tile down, and we're going to put our silicone heat pad right on top of that, just like this. Finally, we're going to get our 12 by 12 mirror tile, line all that up, and set this right on top. Again, you can use glass if you have glass. You can use a piece of aluminum if you really want to. I don't recommend it. I think glass is better. And you can stick this right on top. Then to hold this on, we're going to use the stock binder clips that come in the FT-5 to hold in on the stock heat bed, would be underneath here, and to clip all this down. Once you do that, you have a perfectly flat surface. You have even heat going across it. And I even have a little toy here that we're going to look at, and we can see how well the heat it is displaced across this build platform. So now let me say this about the heat. You're going to have almost a 10-degree difference between what the silicone heat pad is at via your thermistor, which is between the cork and the silicone heat pad. Your thermistor is between the two. So insulation and a hot spot, it's going to read really, really close to what the exact temperature is. But that's not reading what your surface temperature is. Your surface temperature is going to be almost 10 degrees cooler. So you keep that in mind when you're printing, if you're going for ABS, PLA, anything it is, you're going to need to dial up your temperatures about 10 degrees centigrade in order to make sure that the top of your build platform, whatever it is that you're using, meets that temperature. So that is one thing it's not different from using a PCB heat bed, but a PCB heat bed, you just have a piece of glass right on top of that. The heat transfer is very quick, it's right there. The glass we're using is thicker, and again, it just takes time. So be sure that you are checking, give yourself a few minutes. Once it has heated up to that temperature, you gotta let the glass heat up too. So it just takes a few minutes. So just keep that in mind, not a few minutes, a few extra seconds, I guess, 20, 30, a minute at tops, to get everything evened out. Okay, now hooking this up, you have 2 options. One is safer than the other by far. The other one works if you don't have the necessary parts. I ran this silicone heat pad straight off the MKS board for about 4 months, and it performed beautifully. But you have to take care on how you put in your connectors and in how you're heating this up. The MKS board, the connectors on there are only rated at 20 amps. This silicone heat pad, this 12 volt 280 watt silicone heat pad will pull upwards of 23 amps. If it does pull that max load, it does have the possibility to arc on, or to short and or arc those connectors, because they are not rated for a current that high. I'll say current, I guess that's the right word. I'm not an electrician. All I know is it's too high for what's on there. You might pop some fuses, the quick blow fuses that are in the plug, which I had for a while. I think I popped 2 or 3, put a new one in. I've been on that one for 2.5 months now. I haven't blown it yet. So that is the least desirable way. You have to be sure that you seat these cables in straight. They are not against the plastic, because when they heat up, they could melt the plastic, causing the short. There's a lot of worry in there. Does it work? Yes. Is it necessarily safe? Not really. So what are we going to do? We're going to use a MOSFET. And specifically, we're going to use this Trigorilla MOSFET. So this is the one I picked up back in probably October, I guess I bought it on Amazon. Again, links down below for it. And I went ahead and threw on a 40 millimeter, a cheap 40 millimeter fan I got off eBay. I think I got, these were all $1 or $2 a piece. Maybe I think they were $2 a piece. And I bought 10 or 12 of them. So I have a lot of spares. I was able to use them for the fan setups. And this just uses simply 2 M3s that screw right into it. They go straight down and they bite into the huge heatsink that's on this. I mean, huge heat. It's a big MOSFET, but it's an even bigger heatsink. So a lot of heat displacement going on here. This connector here, this big black connector, is rated to 80 amps, which is great. So that means that the amperage is no longer coming off of the MKS board. It's now coming off of this, which clearly can handle a measly 23 amps. So how are we going to wire this up? So right here, I'm going to put a picture up, and you're going to see a top-down picture that I drew of the MOSFET in the middle, and it will show you wires going to and from it. So I'm going to explain this. So up here, we have, up on the top left, we have the 12-volt heated bed. On the right, we have the MKS board, and down below, we have your PSU. Going to the heated bed, positive, negative, don't matter. Going to the MKS board, positive, negative, don't matter. The only thing that matters is positive and negative coming in from the PSU into the MOSFET. Now you see here I already have my fan wired into the power positive and negative. So your PSU is going to go directly into the bottom two power connections. Then from your heated bed is just going to connect to either two. Again, it doesn't matter as long as it's straight in there. You're going to connect the heated bed to the next two connectors, next two terminals on the black connector. So great, we have taken care of that. Now on the other side, we have four connectors. We have a DB ground, and then we have a bed positive and negative. We're going to use the bed positive and negative to hook up into the MKS board. I mean, if you want to keep it, you can keep it positive, positive, negative, negative. Again, the heated bed does not matter, positive and negative, because any of the other heated beds you have, it doesn't have positive and negative lead on it. It's just two red leads. So it really doesn't matter as long as it's connected. If you want to keep them both the same, you can. Now that we have that connected up, we should be good to go. So what we're going to do now is I'm going to bring the FT-5 up here onto my desk. I'm going to show you what the stock setup looks like. I'm going to show you how we're going to install the new setup, how I ran my wires, how I connected into the back, and then we're going to do some testing and see how hot it gets and how long it takes. So let's bring up the FT-5 and get this thing rolling. Okay, so here we are at the back of the FT-5, and here is our stock cables coming in. They come in right here at the bottom. Here's our heated bed, and our thermistor comes right here. So what do we need to do here? We need to disconnect our current heated bed. Again, see how they're both red. Positive, negative does not matter. And we're going to disconnect our current thermistor. So we're just going to pop this out, get our screwdriver.
Disconnect our heated bed leads.
Okay, so now those are out of the way. Just bend those down for now. Now, what I actually do is I actually leave the heated bed wired and wired up in there, and I just leave the connections in here. They're not going to hurt anything because they're not getting power from anywhere. But I do this just in case I was to lose my silicone heat pad. I would still want to be able to do this. So I'm not going to desolder my current heated bed and take it off. It's just silly. It's my backup right now, so that'll work out well if something was to happen. Okay, so now we're going to go ahead and stack on the silicone heat pad up here. So you see I have my glass right now. We're just going to take off our links, take off the glass, and set the silicone heat pad on top of there. So using these stock clamps actually give it quite a good squeeze, which makes it nice and flat. I really like it. And there it is. I mean, you have a super flat surface now. You can see it right there. Okay, so now once this is on there, we need to go ahead and get our MOSFET ready. So we're just going to go ahead, and this is going to go right here. So what we're going to do is we're going to use some of the, I have some extra heavy 16 gauge wire that we're going to run from the power supply into the MOSFET. We'll connect our heated bed to it, and then we'll run a smaller control wire because it's not holding any amperage, it's just purely for control. So we're going to use some Cat 6 and run it from our bed terminal here down to the bed terminal on the MKS board. So we'll wire that up and we'll take a look at it. So actually, before we get too long, this is where my MKS board is going to sit. So I'm actually going to go ahead and mount this here, but I don't want it to sit straight on the melamine. I want it to be mounted up off of it. So the FT-5 comes with quite a few extra spacers. So I'm going to go ahead and use these longer spacers and mount it. I'm just going to center it right here and then mount it right in, and I'll be able to run my wires underneath and pop them right down that little hole that I made, and it'll be ready to go. Okay, so now it's bolted on there real nice. What you also can do is, I had printed one, but I actually don't like the quality that it came out with, as you can actually print a nice little case for the MOSFET. So it comes with the bottom and the top. I actually probably could just use the top on here just to kind of close those electronics in. Again, right now I'm not happy with the print. I even dropped it and broke it, you can see here. And it didn't come out perfectly flat. I had horrible elephant foot on it. It was way too close to the bed. I printed this out like 2 months ago. I'm not happy with it, so I'm going to reprint this, and then I'll probably take this off and remount it. But I just used some extra M3s that I had. I had some Nylox, the spacers that came with the FT-5, so I really wasn't out of pocket for any of these extra parts. They're just things I had from the printer. So I actually didn't realize it till right now that I actually drilled the hole a smidgen too small. I think I just used a 1/4 inch bit, and that was a little too small to fit both of these 16 gauge, so I really sized this up, 16 gauge wires for the power, the actual control cable, and the thermistor. So for now, I'm just going to pass this through here, and I'm going to go ahead and re-drill this with a much larger hole here eventually, and then that will do that. You don't have to run this through here. You could just run it over here to this extra port. So if you could run your motor down through here, all of my motors come down this big bundle here, but you could just run your control wire over here and call it a day, but I'd rather just be in the one hole there together. That's just my choice. So now I'm just going to snip this down to size and connect this to where the heated bed normally would have connected to. Signal cable's connected up. Let's go to close the hatch. We'll spin it around and let's make sure that everything works the way it should. I do want to note here real quick, so you can see here there is a nice little gap for where the cables come out through the cork. So that gives this nice, it's not pinched or anything like that. So you want to make sure you're not pinching any wire, especially the thermistor wire. It is a very fickle device. You can break the glass on the ends very easily, or you can snap the wire very easily as well. So try to make sure you don't pinch that at all. So again, button it up, let's go around front. Okay, we're powered on. It looks like you guys should be able to see that from the view angle, and that's fantastic. So we're going to go ahead, we're going to do control, temperature, down here to bed. We're going to set this to 60°C, way too high, and go. Now we're going to time it and see roughly how long it takes to get up to that temperature. Okay, we're at 60 degrees centigrade on the bed, and that took exactly 2 minutes and 26.17 seconds, as close as I could get it. So not even 2.5 minutes to heat that up. For me, that is a fantastic improvement to where the stock heated bed was taking 10 to 15 minutes to get to 60°C at minimum. That's with the 12 volt PSU overvolted to 15 volts. So this is a huge improvement over top of what was already on there. Now let's take a look at actually the temps on what the bed looks like on top of the glass, and let's look how hot the MOSFET is. Okay, so let's take a look at results. So first here, I'm going to show a couple pictures, hopefully, of what the images looked like for heat. So I have a heat imager that I was able to get a hands on, and I'm going to show you what the heat looks like. So the first thing we're going to look at is the actual MOSFET itself. As you can see, it is running super cool. It was heated to 60°C for 10 minutes. Again, this is just a short test. I could do a much longer test. I will do that eventually in the end, but this was kind of just a quick test on it. But 10 minutes at 60°C after it got to temperature. And the hottest that I could find on there was 31°C, and that's at the 80 amp connector. So that's actually where metal meets metal right there. The heat sink on the MOSFET was at 26°C, and ambient temperature here down in my basement is 21°C. It's a little chilly. So that's not too bad at all. And 10 minutes, no heat whatsoever going to that MOSFET with the fan on there. Probably could take the fan off and it would probably hit no more than 30 or 32°C. So it would be plenty cool. Now looking at the bed, you can see that there's the heat elements in there, the stripes basically. The hottest point on those stripes was 55°C. The coolest point on between the stripes was 50°C. So there is a 5 to 10 degree difference depending on where the stripes are. So you're going to want to adjust your temperature 5 to 10 degrees, whatever you feel comfortable. If you want the most of your bed to be 60°C, you're going to want to bump it up 8 to 10 centigrade on your controller or in your slicer, because if you do it on the controller, you might have thermal runaway. So you kind of have to watch out for that. And then looking through the actual, you can see the PSU in there, and that clocked at 2060 through the melamine, which I thought was pretty doggone warm for sitting there for 10 minutes. I did add an extra cooling fan into the back of my FT-5. If you guys want to see more on that, I can do that again later. But that seems to help out a little bit, not a ton, but it's mainly to cool my board. The PSU is fine in my opinion. The fan is PWM, so it will ramp up when it needs to and slow down when it needs to. So let me also state this. This is not the only way to do this. There are several people out there that have chosen mechanical relays, which are far beyond me. I don't know how to use them. I don't understand them. I just know that they switch things on and off mechanically, hence their name, mechanical switches. They've chose that. They say that is the best option. There's another camp of people that say that an SSR, a solid state relay, is the best way to go. I don't agree with the SSR purely because, again, I'm not an electrician, but from my understanding is that when an SSR has power coming to one side, it will always leak power out of the other. Even though it might be a lot, it might only be a few volts, it still leaks it out. Again, this is my understanding of them. So you have to have an on-off switch separate so that you can power that on and off, because when I shut off my printer with the 12 volt heated bed, it shuts off and it's done. I don't have to worry about it. With the SSR, you either need to make its own on-off switch, or you need to up the fuse, the quick blow fuse that is in the plug currently that comes with the FT-5. It comes with a 3 amp. Well, the plug is rated to 10 amps. If you up that to maybe an 8 amp fuse, that will work. I shouldn't say maybe. It will work because there are several people in the Folgertech group that have done that. So they're having two 120 leads come off of each of parts of the switch, one going to the PSU and one set of hot and neutral going to the SSR. That is completely up to you. However you want to run it is, your call. This is the way that I wanted to use it, and it works perfectly well. There is no downside to this that I can see. Other people might see that, but if you do, hey, you want to leave me a comment, please let me know what you think is a better way. Is this a good way? Is this a bad way? Let me know. Again, I will put links for this little case, which again, I might improve, or I might just reprint this and just put it on the top just so the top is covered so nothing hops on it. Do you need it? No. It's kind of just peace of mind to have it on there. Again, it's just PLA, but looking at the temps, it doesn't get that hot, so I'm not too worried about this warping or melting or anything like that on that device. So that's it, guys. Again, down below, I'm going to put links for all the parts that you need to do this. There's going to be purchase links where you can buy a lot of these things. I picked up this car hookup cable, which is the 16 gauge for the heated bed on eBay. The Cat 6 I had, you can always pick up. You can just grab a jumper, even if it's an old jumper that you're getting ready to throw away. Give it a snip. You only need about 8 inches, 10 inches, so you need a very small piece of the Cat 6 for that, or you could use some of the extra cabling that comes with the FT-5, the 20 gauge. It's just signal cable. There's no real amperage or anything going over it. It is just sending a voltage signal, which the Cat 6 or that small 20 gauge is more than capable of handling that load. And you need the heated bed, obviously, the cork, and you need the mirror tile or glass or aluminum, whatever your preferred build plate is. A piece of ceramic. I've seen people use pieces of tile before. Go to Home Depot, and the tile that you would put in your kitchen or on your patio, those thick tiles, I've seen people use those before too. So your mileage may vary. This is a project that worked for me. I hope it works for you. I hope this explains, hopefully pretty thoroughly, on how to do this. I hope this serves as a good reference for people now and in the future. And I appreciate you watching this. So if you guys like this video, please give it a like. If you didn't, hit the dislike button. Let me know down below. Again, this is how it worked for me. If you have any other concerns or comments, questions, please leave them below. I'm more than happy to answer any and all positive, negative, or neutral comments. If you guys subscribe to my channel, there's going to be a subscription button either here or here. You can go ahead and give that a hit, and you always know when I upload content. If you want to support the channel, you can do that in many ways. The first one being Patreon. There's going to be a link up here and a link down below in the video description. Please send me $1 or more. I greatly appreciate it. My current Patreons, thank you very much. My Patrons that have stayed with me pretty much since the beginning, thank you guys. your funding goes directly into the channel. It helps me fund it. You can also update your links with my affiliate links. So I have an Amazon affiliate link and a MakerGeeks affiliate link. All the products that I purchased down below from Amazon are using my affiliate links. I appreciate you guys using those. That truly funds the channel quite a bit. I've talked about it before. I mean, that helps me out a ton. Even your everyday shopping, if you use that, thank you guys. I appreciate it so much. So thank you for watching. And as always, guys, happy printing.